getting kind of freaky, right? I mean, seriously, you see an article, a blog post, whatever, and you can't help but wonder, did a human actually write this? Or was it some AI just spitting out words?
It is, yeah. AI text generators are getting so good, so fast. And that definitely raises some huge questions for all of us, doesn't it? Like, how can we even tell what's real anymore?
Exactly. And then there's the whole misinformation thing, right? Like, if anyone can create believable looking news articles or social media posts with AI, forget about it.
Yeah.
It just gets so much harder to separate fact from, well, fiction.
Absolutely. And plagiarism. Oh man, that's a whole other can of worms now. Like, what even is plagiarism in the age of AI?
It's wild, right? Okay, so all that to say, we're diving into the deep end on that today. We've got this research paper, feature-level insights into artificial text detection with sparse autoencoders. A bit of a mouthful, I know. But the folks behind it are legit. We're talking Skolkovo Institute of Science and Technology, the AI Foundation, Moscow Institute of Physics and Technology, a bunch more. It's a real brain trust.
Right. And what they're doing is super cool. They're not just trying to build like a better AI detector. They're actually trying to peek inside the AI's brain, so to speak. See what makes its writing tick, you know?
That's what I love about this, is like, instead of just playing whack-a-mole with AI text, we're trying to understand how it works at a fundamental level. So for everyone listening, that's our goal today. Break down the key takeaways from this research. What sets AI writing apart? How can we spot it? And why does all this even matter to, well, to you and me?
Exactly. I think the first thing we need to unpack is why detecting AI text is even such a problem in the first place.
Right. Like, why can't we just, I don't know, run a spell check or something and have it flag the AI stuff?
Well, think about it. A lot of the AI detection tools we have right now are basically these black boxes. They spit out a percentage, say 90% chance this is AI, but they don't really tell you why they think that.
Oh, okay, I see. So it's like, yeah, you might get a warning, but without knowing why it's a warning, it's tough to really trust it.
Yeah.
Right.
Precisely. That lack of interpretability, it's a big deal, especially when you're talking about, say, news articles or legal documents. You need to be able to explain why you think something's AI generated, not just throw out a number.
Gotcha. So back to the research paper. How do they address this black box problem? What are these sparse autoencoders they keep mentioning?
Okay, so a sparse autoencoder, or SAE, it's a type of neural network, right? But the sparse part is key. It means the SAE is forced to focus on just the most important, most distinctive features of the text it's analyzing.
So it's like, instead of describing every little detail, it's picking out the key identifiers, the things that really make AI writing stand out.
Exactly. And by doing that, by focusing on these sparse features, it actually makes the SAE's analysis more understandable to us humans. It's like the SAE is giving us a simplified, interpretable version of what the AI is doing.
That's really neat. So they're using these SAEs to analyze AI text, but how are they actually getting inside the AI, to see what's happening?
So what they did was they focused on what's called the residual stream of a specific language model. In this case, it was Google's Gemma 22B. Think of the residual stream like a central pipeline, where information flows between the different layers of the AI's neural network.
Oh, interesting. So by looking at this pipeline and what's being passed along, they can sort of see how the AI is processing language.
You got it. And they found all kinds of fascinating features in that residual stream. They grouped them into 3 categories: discourse features, which look at how the AI connects ideas and builds arguments; noise features, which point to weird inconsistencies or artifacts that humans probably wouldn't make; and style features, which capture the style of the writing, the choices it makes in terms of vocabulary and sentence structure.
Right, and they were able to use these SAEs to actually detect AI-generated text.
They did, and the results were really promising. They proved that focusing on these specific interpretable features could make a real difference in how effectively we can identify AI text.
I love that. They're not just improving detection, they're helping us understand why. All right, so they've got their tool, the SAE, and they're looking inside the AI's brain. What kind of text did they use to train the system?
They used 2 main data sets. The first one, the Coling data set. That was their primary source. It's huge and super up-to-date. And here's the really important part. It includes text from tons of different AI models, from the older ones like MT5 and OPT, all the way to the really advanced ones we hear about all the time, like GPT-4o and Llama 3.
Wow, so it's like a who's who of AI language models, past and present, and the other data set.
That was the RAID data set. They used this one to test how well their features held up against, well, basically attacks. Like, what if someone tries to disguise AI text by paraphrasing it or using tricky character substitutions? RAID includes examples of these attacks so they could see if their detection method could still spot the AI, even when people were trying to hide it.
Okay, so we've got this huge collection of AI-generated text. I'm assuming they also had some human-written text too, right, for comparison.
Right, absolutely. You need that baseline. You need to know what normal human writing looks like to spot the things that make AI writing different.
Makes sense.
Yeah.
So they crunched all this data, and what jumped out? What were the big takeaways?
One of the coolest things they found was the difference between general features and domain model specific features. So general features, those are the things that seem to show up in pretty much all AI writing, regardless of which AI model created it or what it's writing about.
So it's like a telltale sign that screams, hey, this was written by AI.
Exactly. And then you have these domain model specific features. These are more specialized. They might be really good at spotting AI text from a specific model like GPT-3 or in a specific subject area like science articles, but they won't necessarily work across the board.
That's really interesting. So are there some, like, I don't know, fundamental quirks that AI just can't seem to shake no matter what? It sounds like there's kind of a universal AI writing style.
That's what their research suggests. A lot of their analysis focused on the 16th layer of the Gemma 2.2b model. They found that this layer was especially good at revealing these universal AI features. Two in particular, features 30608 and 4645, popped up as being super important.
Okay, so what do those features actually tell us? Like, what makes those pieces of AI text stand out?
They actually did some clever things to figure that out. They did manual analysis, which basically means they looked closely at the text that triggered these features, trying to spot patterns.
Mm-hmm.
And they also used this technique called feature steering, where they could kind of dial up or dial down the influence of a specific feature and see how it changed the AI's writing. It's like they were poking and prodding the AI to see what makes it tick.
Haha, I love that. Okay, so feature 3608, what's that one all about?
So 3608 seems to be all about excessive complexity. They found that AI text often gets way too complicated in its sentence structure. Like it might use way too many clauses or just sound overly formal and academic, like it's trying too hard to sound smart.
Right, it's trying to impress us with its big words and complicated sentences, but it just ends up sounding weird.
Exactly. And then there's 4645. This one seems to be related to how assertive the AI is. Like, it might make claims that sound really confident, even if it doesn't actually have the evidence to back them up.
Uh-oh. So it's like the AI is bluffing.
You could say that. And what's even wilder, they found that this feature sometimes popped up in text that was actually contradictory. Like, the AI would say one thing and then say the opposite a few sentences later, which, most humans wouldn't do.
No, not unless they were, really confused. Or maybe a politician.
Right. They also found feature 6587, which is linked to these long, rambling introductions. The AI might take forever to get to the point, kind of like a professor who loves to hear themselves talk.
Oh, yeah, I've seen that. It's like, just answer the question already.
Right. It seems to be a real thing with AI. They even noticed that this feature often activates in structural elements of text, like bullet points or numbered lists. Like, even in those simple things, the AI can get a little too wordy.
This is fascinating. So we've got some general AI quirks. What about the GPT models? Did they find anything specific to those?
Yeah, so there were two features that were particularly good at detecting text from GPT 3.5 and later. Feature 8264, which almost perfectly identified GPT 3.5 plus text, seems to control how concise the writing is. But in the AI's case, it often leads to unnecessary repetition. It might rephrase the same idea multiple times, just using slightly different words.
So it's like it's stuck in a loop repeating itself without really saying anything new.
Right. And it also tends to use these long, complicated words, even when a simpler one would do. They found that this feature often activated on these really common but long words that GPT seems to love, almost like it's showing off its vocabulary.
Yeah, like it's trying to sound super smart, but just comes across as, I don't know, kind of clunky.
Exactly. And then there's feature 8689, which is linked to this tendency to overuse synonyms. Basically, the AI might replace words with synonyms even when it doesn't really add anything to the meaning, just to sound more varied.
Interesting. It's like those students who try to cram as many fancy words as they can into an essay, even if it doesn't make sense. Okay, so that's GPT. What about other types of AI text? Did they find any patterns there?
They did. They found all kinds of domain-specific features. For instance, with scientific articles from Mark Sulve, they found this feature, 12390. that triggers on overly complicated sentence structures. Like the AI might use the right kind of linking words and phrases for scientific writing, but it just overdoes it. It's like it's mimicking the style without really understanding the substance.
That's trying to sound like a scientist, but ends up just sounding, well, robotic.
Right. And with finance text, they found feature 6513, which activates when the AI gets bogged down in way too much detail. And weirdly, it also seems to trigger on text that's kind of informal or opinionated, which you wouldn't necessarily expect in financial writing.
Huh, that's interesting. Like it's trying to be chatty about stock prices.
Yeah, kind of. On Reddit, feature 4560 seemed to light up when the AI was making these speculative connections, implying things were related without any real evidence. And it also activated on like informal internet slang and stuff. Like it was trying way too hard to blend in.
That's so awkward. It's like your dad tried to use teenage slang.
Exactly. And for Wikipedia text, they found feature 4773, which seems to pick up on this weird word flexibility. Like the AI might try to be creative with its language and end up with these nonsensical phrases, almost like it's hallucinating facts.
Oh, that's creepy.
It is. And then there's medical text. Feature 14953 seems to trigger when the AI gets too bossy, like giving direct instructions in a medical context, which could be really dangerous.
Yeah, you don't want your AI doctor telling you what to do without, actually knowing what's going on.
Right. It's like, take 2 aspirins and call me in the morning, but it hasn't even examined you.
Yikes. Okay, so lots of fascinating patterns there. They also talked about how some types of AI text are harder to detect than others, right?
They did. They found that the toughest domains for detection were the ones where the AI could really successfully mimic human-like writing. Things like essays or customer reviews. When the instructions given to the AI specifically told it to write in a more natural, informal style, those general overcomplexity features we talked about earlier became less reliable. It's almost like the more you try to make the AI sound human, the harder it is to spot.
That makes sense, but that's kind of scary, right? If we're heading towards a future where AI can just blend in seamlessly with human writing, how are we going to know what's real?
It's a huge question, for sure, and it highlights the importance of this kind of research. We need to keep digging deeper, understanding the nuances of AI writing so we can stay ahead of the curve.
Absolutely. So what about those superficial features and the attack strategies they talked about? Did those throw off their detection methods?
Interestingly, no, not really. They did find some features that were sensitive to things like text length or weird formatting, like too many line breaks or unusual punctuation. And those features were easier to manipulate with those attack strategies. But those weren't the features that were most important for overall AI detection. The core features they identified, the ones that really seemed to capture the essence of AI writing, those were much more robust.
That's good news, I guess. It means it's not that easy to fool these detectors with simple tricks.
Right. It suggests that there are some fundamental differences in the way AI writes, differences that go beyond just surface level stuff.
Okay, last thing before we wrap up. You mentioned earlier how they use this feature steering technique. Can you tell us a little more about that? Like, what did they learn from it?
So with feature steering, they could basically tweak these individual features and see how it affected the AI's output. It's like they were messing with the AI's settings, turning knobs up and down to see what would happen. And the results were pretty wild. For instance, they found that by increasing the activation of that finance-related feature, 6513, they could actually make the AI's opinions sound more positive. Like they could literally manipulate the AI's emotions.
No way, that's crazy.
Yeah, and with feature 1416, the one that detected missing formulas in WikiHow, they found that it actually boosted the AI's creativity when they turned it up in fictional writing. But in other contexts, it actually made the AI hallucinate facts, just make stuff up.
So it's like this feature controls the AI's imagination, but it can also make it go off the rails.
It seems so. And then there was feature 14953, the one related to medical text. They found that by increasing its activation, they could actually make the AI sound like it was giving legal advice. It's like they were switching the AI's profession just by tweaking this one little feature.
That is just mind-blowing. It's like they're revealing these hidden levers that control how the AI thinks and writes.
Exactly.
Okay, so big picture time. What should we take away from all this?
I think the main takeaway is this. AI writing, even from the most sophisticated models, often has these detectable patterns. Things like overly complex sentences, repetitive phrasing, weird word choices. But those patterns can be harder to spot when the AI is specifically told to write more naturally, more like a human. And this research shows that by understanding the inner workings of AI, by using tools like Sparse Autoencoders to look at these hidden features, We can get better at both detecting AI text and understanding how it's created.
So it's an ongoing battle, right?
Yeah.
As AI gets better at mimicking human writing, we need to keep developing new ways to understand and detect it.
Exactly. And the researchers highlighted some really important directions for future work. Like AI models are evolving so quickly, we need to keep up. And interpreting all these SAE features, figuring out what they really mean, that's still a challenge. Plus, they only looked at one model in this study, so there's a whole universe of other AIs out there that we could analyze.
Lots more to explore then.
Tons.
Well, this has been a wild ride. It's crazy to think that there's this whole hidden world inside AI, these tiny features that control how it writes and thinks. And now that we know they exist, it really makes you question everything you read online, doesn't it?
It does.
So, here's something to ponder. If we can learn to decode AI's writing style, could we also learn to manipulate it? Could we use these insights to make AI write even more convincingly, even more like a human? Or could we use them to create even better detection tools that can keep up with the ever-evolving world of AI? It's a fascinating and maybe even a little unsettling thought. Thanks for joining us on this deep dive. It's been a real eye-opener.